Hello there, my name is Tero Hannula, and today we will make some functions to save and load neural network in JSON. Just to remind that all is done in Copier Studio 2.3. In previous videos we have made a network and we can train it, so saving the results would be nice. Otherwise we would need to retrain network every time we close our game. You can do this in many different ways, and for this video I decided to use JSON format. JSON is a standardized format for storing information as a readable text. The structure and data are shown clearly and explicitly, which can also be parsed easily cross-platform. What's more, GMS2 has built-in functions for stringifying and parsing, so we can use those. Although we could just throw our network directly to built-in stringifier, we don't want to do that. Instead, we use dummy layers to only capture necessary information, but also to avoid circular struct references. The former is just preference, but the latter would cause things to fall apart with an infinite loop. So instead of network, we will actually stringify an array of dummy layers. These layers are just temporary and only reference existing parameter arrays and hold up a couple of variables. The GMS2 can easily stringify these dummies without a problem. The wanted information varies between layer types, but we want to always store type and size. In dense layer, we want to also store index for activation function and parameters for weights and biases. After creating dummy layers, our function will stringify them as JSON and return it, which can then be used and stored in various ways. Let's quickly test our function works and network is stringified properly. I'll set the result in the clipboard, which I can paste into Notepad. With JSON, we can verify it easily by just reading it. It seems to be working, so let's continue. Now of course, we want to be able to read this string back later, so let's do the parser. GMS2 parser will create plain structs and arrays, and can't use our network constructors. You could think this way. We are parsing information first into dummy layers, so they don't have method functions or other information, only things we have stored previously. So we will have to create actual layers separately using these dummies. Overall, our parser is pretty simple with simple error checking. If a string was valid JSON, we can create empty network and then use parsed dummy layers to fill it up. We will first create a correct structure by using our previously made layer builder. We can just call builder methods using dummy layer information as arguments. After this, we will need to copy over the parameters. I'll have this in a separate function too, so it can be used as a standalone function. Here again we have a switch statement as different layer types could have different parameters to copy over. I also create another function to copy all parameters to the whole network from another one. But we can only copy parameters if networks share same structure, so I add a few checks here. This whole network copier is just for convenience. For parsing we only needed layer copying. For testing, I will copy parsed network to the whole population, so it is more apparent that something had happened. You wouldn't actually want to do that, as a genetic pool would get quite poor. Now, given text can also be invalid, so you should check whether parsing was successful before taking any action. So now we are able to stringify and parse, but also copy a network. So we can now store and retrieve them. Let's try first with the invalid string what happens. Okay, game didn't crash. Good. Next, I'll copy network from a single specimen to the clipboard. This seems to be correct. Now, when I paste this network back to the game, it loads it to the whole population. So all specimen should behave same. And yeah, it seems so. I had copied a bad specimen, so after loading I'll behave bad. Next, let's try training population first, and then save one of them. After training, let's also reopen the game, so there are no remnants from training and loading wasn't fluke. Now that the game has been restarted, let's see if we can load the network to the whole population. Ah yes, it seems to be working. And our little guys do better job at avoiding the blocks. Okay, so we have a saving and loading done by using JSON format. It was pretty easy. Though we have a problem. In a string, each character uses 1 byte of memory. So representing a number, we use up as many bytes as there are digits. For example, here's one number from JSON string. Representing this number needs more than 30 bytes. And this is just a single parameter. In neural networks, we may have hundreds of thousands of them or millions. So our number representation is wasteful in the memory. By using 64-bit floating point numbers, we could represent this number with just 8 bytes. Most likely we don't need to be this accurate either. Instead, we could store them as a 32-bit numbers. This means 4 bytes. In JSON, this gives you only 4 characters for a string, and you already spend 1 character for the dot. So floating point numbers are great, but we can't use them in JSON, as they are not supported there. Instead, we can use another way, buffers. This will give us more control on how numbers are stored, but also numbers don't need to be parsed, because they can be read directly. But that will open another kind of forms, which I will leave for the next video. See you then, and hopefully sooner than last time. Pahoittelut, että kesti, mutta mukavaa päivän jatkoa silti. Moikka!